Last month, the interstellar object known as 3I/Atlas made a rare and remarkable approach within just 18 million miles of Mars, following an unusual and highly eccentric trajectory through our solar system. The object's path has captured the attention of astronomers worldwide because it represents only the third confirmed interstellar object observed passing through our planetary neighborhood, following in the footsteps of the now famous Oumuamua and 2I/Borisov. Unlike typical comets or asteroids originating within the solar system, objects like 3I/Atlas come from the vast reaches of interstellar space, carrying with them valuable information about conditions and materials far beyond our sun's influence. As a result, the scientific community has been eager to examine it closely, hoping that the data gleaned from its passage could shed light on the composition and dynamics of objects that originate in other star systems. During its close approach to Mars, NASA's Mars Reconnaissance Orbiter, (MRO), used its high-rise, high-resolution imaging science experiment camera to capture detailed images of the object, producing the highest resolution photographs of 3I/Atlas to date. HiRISE, which has previously provided unprecedented views of Mars' surface, is capable of resolving objects as small as a few meters across from orbit, making it an ideal instrument for studying this interstellar visitor. The images, however, have yet to be released publicly due to bureaucratic constraints arising from the federal government shutdown that began just days after MRO captured them. This delay has left astronomers and space enthusiasts alike waiting for over a month to see the clearest pictures of an interstellar object humanity has ever captured. Recognizing the significance of these images, U.S. Representative Anna Paulina Luna, Republican Florida, took action last week by sending a formal letter to interim NASA Administrator Sean Duffy. In her communication, Luna emphasized the scientific importance of releasing the high-resolution images, noting that they provide approximately 3 times the resolution of previous images taken by the Hubble Space Telescope in July. Hubble's images, while groundbreaking in their own right, had limitations in discerning fine details of the object's structure and size. The HiRISE data, by contrast, could allow astronomers to make the most accurate estimates yet of 3I/Atlas nucleus size, as well as study the characteristics of its coma, the cloud of gas and dust surrounding its core. This information is of great importance to advancing our understanding of interstellar visitors and their interaction with our solar system. Luna wrote in her letter, "The brightest pixel in these images will provide our most precise constraint on the object size to date." Her statement underscores the critical nature of high-resolution observations for interstellar studies. In addition to size measurements, the clarity of these images may help scientists identify surface features or activity patterns, such as sublimation of volatile materials or the presence of dust jets, which could provide insights into the physical and chemical properties of the object. These observations could also be essential for refining models of how interstellar objects behave when entering a new star system, offering broader clues about planetary formation processes and the dynamics of interstellar debris. NASA has acknowledged Luna's request, but the response has been tempered by the ongoing government shutdown. According to Luna, the agency indicated that it cannot release the images until the federal government reopens, despite the scientific urgency of the matter. "Just had a good conversation with NASA regarding 3I/Atlas," Luna tweeted. "As soon as the government reopens, they'll be releasing images/data. Unfortunately, due to bureaucratic reasons, they cannot until then." While this delay is frustrating for the scientific community, it does highlight the challenges of navigating large institutional protocols in the midst of political and operational disruptions, even when dealing with events of potentially groundbreaking significance. In the meantime, other observations have partially filled the gap. Harvard astronomer Avi Loeb, who has been collaborating with Luna on advocating for the image release, pointed out in a recent blog post that NASA is not the only organization capturing high-resolution views of 3I/Atlas. The China National Space Administration (CNSA) has released images taken by its Tianwen-1 Mars orbiter, which carries the high-resolution imaging camera, HiRIC. Impressively, Tianwen-1 came within just 18,000 miles of the interstellar object, capturing detailed imagery of both the nucleus and the surrounding coma. These images reveal a glowing cloud of gas and dust several thousand kilometers across, illustrating the complex nature of 3I/Atlas and providing valuable comparative data alongside NASA's yet-to-be-released HiRISE photos. The scientific implications of these observations are profound. According to Loeb, analyzing the HiRISE and eventual HiRISE images could help determine the size and mass of 3I/Atlas more accurately than ever before. Loeb's previous calculations suggest that the object could be anomalously massive, featuring a solid density nucleus larger than approximately 3.1 miles across, with a total estimated mass exceeding 33 billion tons. These figures, if confirmed, would make 3I/Atlas one of the more substantial interstellar objects observed passing through our solar system, raising questions about its origin and the processes that shaped it over millions of years in interstellar space. Adding to the intrigue, 3I/Atlas has demonstrated behavior that deviates from what astronomers typically expect from comets. Images captured on November 5th by the Naves Observatory in Spain reveal that the object lacks a visible tail, even though it had recently passed its perihelion, the point in its orbit closest to the Sun. For most comets, this part of the orbit triggers intense sublimation of ices and the ejection of dust, forming a prominent tail that extends away from the Sun due to radiation pressure and the solar wind. Loeb calculated that during its perihelion passage, 3I/Atlas should have lost more than 13% of its mass, a quantity that, under normal circumstances, would generate a noticeable tail. The absence of such a feature in the images is perplexing and challenges conventional understanding of cometary physics. Some researchers, including Loeb, have speculated that these unusual observations might suggest extraordinary origins for 3I/Atlas. In his writings, he has entertained the provocative hypothesis that the object could be a relic of an extraterrestrial civilization, deliberately sent towards the inner solar system. While this idea remains highly controversial within the scientific community, it illustrates how anomalies in observed data can spark new theories and debates, pushing the boundaries of astrophysical inquiry. Even if the object turns out to be a natural interstellar body, the deviations from expected cometary behavior provide a unique opportunity to expand our understanding of materials and processes beyond the solar system. As the scientific world awaits the release of NASA's HiRISE images, the combined data from multiple spacecraft will offer an unprecedented chance to study a visitor from another star system in extraordinary detail. The observations from EMRO and Tianwen-1, together with ground-based telescopes like those in Spain, create a multi-angle dataset that could answer long-standing questions about the structure, composition, and dynamics of interstellar objects. Moreover, understanding these objects is not only academically intriguing, but may also have practical implications for planetary defense and future exploration missions. Studying the size, mass, and composition of interstellar bodies can inform models of potential impact hazards and help refine detection strategies for future interstellar visitors. In conclusion, the story of 3I/Atlas demonstrates both the opportunities and challenges of modern astronomy. A rare visitor from interstellar space has passed close to Mars, captured in stunning detail by multiple space agencies. Yet bureaucratic delays have temporarily limited access to the most crucial images. Meanwhile, astronomers continue to analyze available data, noting unexpected features and considering bold hypotheses. Whether or not 3I/Atlas ultimately proves to be a natural comet or something more unusual, its passage through our solar system represents a landmark event in the study of interstellar phenomena, highlighting humanity's growing capability to observe and understand objects originating from the far reaches of our galaxy. As we await further data, the excitement and curiosity surrounding this mysterious traveler continue to build, promising new insights into the universe beyond our solar neighborhood.